So in this video, I'm going to continue our discussion with exponent rules, and there's one thing that I need to mention about the negative exponent rule before we move on, and that is we always want to answer our questions with positive exponents. So if you have something like x to the negative 2 and y to the negative third, we need to use the negative exponent rule to answer with positive exponents. So if I bring the y to the negative third to the denominator, from the denominator to the numerator, then it would become positive, and that would be the same, but kind of the opposite for the x. If I bring it from the numerator to the denominator, it becomes positive. And so we always want to answer with positive exponents. So that would be one example. What's another one? If I had 1 over z to the negative 7th, I can rewrite this as z to the 7th. Okay, so we always want to answer with positive exponents, and be sure that you are doing so in your own work. Okay, continuing on, let's talk about the power of the product rule. Now, this is where usually we kind of, unless we're reading a math textbook, we don't really, define them by their names anymore. We start to just have to understand how they work when they are combinations of the rules. So here is the rule: any number a times any number b to some exponent could also be written as a to the exponent times b to the exponent. So really we're just distributing the exponent in this way, and we're doing it through multiplication, so that's where the product rule comes from. And since this is a power, that's where the power is. So it's kind of just saying, how does multiplication work with exponents? And the truth is, you just individually put them there. So let's look at an example and see if it's easy or not. I'm going to pick on 2 and 3 because they're just easy to work with. So 2 times 3, and let's say that that is squared. I am claiming that you can write 2 squared times 3 squared, and that these are equivalent statements. Let's go ahead and check and see if they are, because this is simple enough where we can check by hand. So 2 times 3 is 6, so I claim that the left hand is 6 squared, which is 36. And then we have 2 squared, which is 4, and then we have 3 squared, which is 9, and 4 times 9 is also 36. So yeah, this works. So this is how the power of the product rule goes. Again, I'll never ever ask you what is the name of this. It's more of just, can you use it? Let's look at some where we have some variables, and we can see how this works. I might get rid of this too, just for some room. Let's do this example. X to the negative second, z squared to the 7th. Let's see if we can simplify this. Okay, we have a negative exponent. We might have to deal with this, but the power of the product rule says that you can distribute that 7, and so we'll need to multiply. So we have x to the negative second times 7, and then this would be multiplied by z times 2 times 7. Okay. Now, negative 2 times 7 would be x to the negative 14, and z to the 2 times 7 would be positive 14. And since this is a negative exponent, I want to answer with a positive exponent, so this is going to go to the denominator. So this would be z to the 14th over x to the positive 14th. Okay? So that would be my final answer. All right? So I hope that helps of understanding what the power of the product rule and how multiplication works with exponents. Let's look at how dividing or fractions work with exponents, and it's pretty much as you would expect. It's pretty straightforward. So if you have a over b to the n, just like before, we distribute, or we're allowed to distribute that exponent. Okay, so I can have a to the n over b to the n. Okay, let's look at an example and see how that might work. So an example might be 2 over x to the 11th. And let's say that is to the 4th. So you would have 2 to the 4th, and then x to the 4 times 11, and to the 4th. So that would be 16, and x to the 4 times 11, that would be x to the 44th. And we have positive exponents, and there's no variable in the numerator, so this would be the final answer. Okay? So you can, basically I'm saying that you can just distribute the exponent for both division and multiplication. There's another thing I want to show you. It's actually simpler than what we just talked about, but it comes up a lot, and that's just how do simple fractions work with exponents. In case you didn't know, you can use this again. So 1 squared over 2 squared is 1, because 1 times 1, and 4. So that'd be 1/4, right? Or if you had something like 3/4, let's say let's just square it again. So that would be 3 squared over 4 squared. That's 9/16. And then you reduce if you can, but 9/16 you can't reduce, okay? So I hope that at least gives you a leg up on how the power of the quotient rule works, or in plain English, how does division work with exponents, okay? So you can distribute the exponent. All right, last thing is scientific notation. This is part of the class that we need, or it's one of the staples of the class that we need to go over in case you go into a scientific path in your studies. We need to go over scientific notation because it'll be required. So, scientific notation is just that. It's a notation. It's no deeper than just a way of writing down numbers, okay? We're not actually changing the value of a number with this notation. We're just changing the way we write it down. The notation is just changing the way we write something down. So I can use scientific notation to rewrite the number 1. Well, why would you do that? You wouldn't. But scientific notation is really for writing very large numbers and very small numbers. But I just want to show you how this will work. So maybe I'll use a different color just so you can see what I'm writing. But 1 equals 10 to the, now I need to write the exponent, and that would be the 0th from the 0th exponent rule. 10 equals 10 to the 1st, right? So it's just 10 times nothing, or, it is 10, right? So 10 to the 1st is 10. Now, 100 has 2 zeros, and that would be 10 times 10, so that's 10 squared, okay? Now, 1,000 has 3 zeros, so that'd be 10 times 10 times 10, so that'd be the 3rd. 10,000 has 4 zeros, so I can go, that's 10 to the 4th. 100,000 has 5 zeros, so that's 10 times itself 5 times. And 1,000,000 has 6 zeros, so that would be 10 times itself 6 times, okay? And it really is just that. You're counting the zeros. Some students think of it as you're just moving the decimal place. And that's okay with me too. But yeah, you're just counting the zeros. We can also do that for numbers that are less than 1. So if you have something like 0.1, again, this has 1 0, but it's less than 1. So this is 1/10, 1 over 10. This is our negative exponent. So 100th, 1 over 100, that's 2 zeros, so that'd be -2. 1/1000th is 3 zeros. You can see that. And so on. -4, -5, -6. So 1/1,000,000th is -6. 1/1,000,000,000th is 10 to the -9, and so on. 1/1,000,000,000,000th, -12. So it really is that. That's as deep as it is. It's just a way of writing down different numbers. There are a few other things I want to show you about scientific notation, and that is how you can multiply numbers with scientific notation. So let's take a look at this example. Let's say I have 2 times 10 to the 5th times 5. Oh, you know what? I'm going to let's do 4 for this first example, times 10 to the 7th. Let's try this. Okay. So for this one, I can go 2 times 4, which I know is 8, and then times 10, and since these are the same base, I can add the exponents. So this would be times 10 to the 12th, okay? So that's not too bad. The reason why I was cautious to not use the example I almost wrote down, which I think I almost wrote down 10 to the 5th times, what did I say, 5 times 10 to the 7th, is this. 2 times 5 is 10. For one reason, that's very confusing. It's 10 times 10. This would also be to the 12th. That's still true. In scientific notation, we always use just one number, just like this, one number left to the decimal place. So 2 times 10 to something, 4 times 10 to something, 1. So you can only use numbers 1 through 9 with scientific notation. So I actually need to change this to a 1 times 10, and since I made this smaller, I need to make this one larger, so that'd be 1 times 10 to the 13th. Why do we do this? Well, again, it's just a notation. It's just a way of rewriting numbers in this notation, so it's easier to understand 1 with 13 zeros on it, okay? There's no deeper meaning behind scientific notation, but that's how it can work. Let's look at another example, and this one is a little bit more complicated. Let's look at something like 3.14 times 10 to the negative 7th. I'm going to move that down just to be sure that you're able to see that. 3.14 times 10 to the negative 7th. And I'm going to put parentheses so it's clear where 1 ends and 1 begins. 1.41 times 10 to the 10th. Okay, I'm going to multiply these, all right? So the first step is just you can multiply 3.14 times 1.41. Okay, well, if you do it in your calculator, you get something like 4.4274 times 10. And then this would be negative 7 plus 10, so that'd be to the third. Okay. Now, the understood rule of rounding for scientific notation is that you cannot answer with more information than you were given. I was given 3 digits of information here and 3 digits of information here, so I can technically only answer with 3 digits of information. So this 2 is going to have to change, or I'm going to have to evaluate if I'm going to change it. I look at the next one, it's a 7, which is greater than 5. So this 2 is going to have to go up 1, so that I'm going to have to round this and put a little rounding that I did round that, be 4.43 times 10 to the third. Okay. Yeah. So this is how sometimes in science classes this would be called significant figures or whatever. But this is the understood way of rounding, okay, for these types of problems. And that might be a little confusing, so maybe we should do at least one more example. Let's try dividing this time. 1.2 times 10 to the 8th divided by 9.6 times 10 to the 5th. Okay. So what do we find? Well, when I do this in my calculator, I got 1.2 divided by, sorry, it wasn't pulled up. Let's see. 1.2 divided by 9.6, I get 0.125, okay, 0.125 times 10. 8 minus 5 is 3, all right, but I need to adjust this. I don't want the 0. I need this to be a number between 1 and 9, so I can rewrite this as 1.25 times 10, and I made this larger by 1 decimal place moving, so I need to make this smaller, so this would be squared, okay? Now let's check for our rounding. I have 2 digits of information here and 2 digits of information here. I can only go with the smallest, and that would be 2. So I need 2 digits here. I look to the next number. It's 5, so I need to round. This would be 1.3 times 10 to the second as my final answer. Okay. So please don't get hung up on rounding or be scared by rounding. This is kind of a one-off for this lesson for our class. When you take science classes, or if you take science classes, you will go further into rounding and how that works, and your particular profession may round a certain way. But right now, this is kind of a one-off and just an exploration of exponents. Again, I hope that helps. Please let me know if you have any questions, and I will talk to you later.